today is Monday, November 11th, and you are watching Iron Culture, presented by Mass. And hearing that title might be a surprise to you. If you are a regular listener of Mass Office Hours, you know that we moved this episode to Monday, something that is completely unheard of. There is no precedent for it. And the reason is, this is a very special episode with a whole bunch of big announcements about the future of not only Mass Office Hours, but other podcasts that you know and love. So if you are a regular listener of Iron Culture and you haven't heard today's episode that went live earlier today on all the podcast platforms, I've got some big spoiler alerts for you. Most notably, our dear friend, the good almost Dr. Omar Yusuf. I feel like he's a doctor by osmosis as being part of the Iron Culture crew. But anyway, Omar today announced in episode 300 of Iron Culture that he is gloriously stepping away in victory, not cowering away with his tail between his legs. He absolutely accomplished everything someone would hope to accomplish in a 300 episode run. And if you want to hear more about what he'll be up to, why he's stepping away, and all sorts of thank yous and general good vibes, make sure you check out episode 300 of Iron Culture, which just went up and was posted today. But Helms, that leaves us in an interesting situation. We find ourselves on a Monday, of all days, when we normally do Mass Office Hours live. We are on YouTube on a Monday. Iron Culture is clearly in upheaval. There is a massive shuffling, so we need to clear the air about what's going on in the future, give people an idea of what to expect. So, Helms, you and I, obviously Omar, solid dude. He told us well in advance, like, hey guys, I'm thinking, time to start planning my exit, which was very cool because no one likes a podcast emergency. It's already such a high stakes business. The last thing that you need is short time. So we had plenty of time to plan out, what do we want to do as our dear friend Omar steps away. And Helms, frankly, we looked at our plate and said, okay, we really don't have a need or, frankly, a desire to run 2 weekly podcasts with extremely substantial content overlap and personnel overlap. Kind of doesn't make a lot of sense to have dueling podcasts every week. So the big announcement for tonight is that we are merging Iron Culture with Mass Office Hours. The result will truly be a blend of both entities. It will be called, as I mentioned at the top of this show, Iron Culture presented by Mass. And the idea for our schedule is that on Monday evenings, our episodes are going to go up on YouTube. Those episodes are typically going to be live, which means there's going to be opportunities for questions. So Monday episodes will go up on YouTube, but that'll go up for now. We're planning on both the Mass YouTube channel and the Iron Culture YouTube channel. So wherever you like to get that content, you can get it from the exact same place. Now, 2 days later, on Wednesdays, we are going to put the episodes up on podcast platforms. And again, for now, we want to make the transition as easy and painless as possible. So for now, we're going to be publishing those episodes to both podcast feeds. So as a listener, nothing's really changing. If you got your Iron Culture at Iron Culture, you're going to still be getting your Iron Culture. And if you were really adamant that you need your Iron Culture on Monday, every single Monday, we are still making good on that promise via the YouTube presentation. The YouTube episodes on Mondays are usually going to be live. Obviously, sometimes we're going to have pre-recorded stuff that goes up instead. As for the content of the show, like I said, it will truly be a blend of Mass Office Hours Live and Iron Culture. There will be some episodes that are dedicated question and answer episodes from start to finish, where the live chat can get all their fitness and science questions answered. Some episodes are going to be more like your typical Iron Culture episode, where it'll be a predetermined topic where we do a deep dive, or maybe even have a guest join us to talk about a topic where perhaps they have a great deal of experience. It'll be a mixture of science, practical application, and other topics relevant to lifting culture. I'm not saying it'll be every week, but I'm sure Helms is going to be bringing on a historian from time to time talk about what bodybuilding was like in the 1400s. That's just how iron culture works, folks. But a lot of science, a lot of practical application, and a lot of other stuff that fills in those miscellaneous topics in lifting culture. Helms, at this point, I want to turn it to you. Is there anything I missed? I've been working all day. I'm very tired. Is there anything I misspoke about? Fill in the gaps. Tell the people what they want to hear.
No, you did not. You didn't miss a thing. And I just want people to understand that we are primarily doing this just because Dr. Trexler is an incredibly hardworking individual, and we need to protect this man. He does a lot. He does too much. And if we were to continue with him hosting 2 weekly podcasts on top of a role at Duke, being the primary content contributor to Mass, and also just trying to be a good, balanced human with his new wife, man, I just feel that we would be pushing the limits of his soul. He would adapt, of course, but why would we do that? We have to protect this man, like I said. So this is not just simply a corporate shill takeover of iron culture. It is that to some degree, because we are now presented by Mass, which you know is a multi-conglomerate, multinational, publicly traded company that has no heart or soul.
But we do have shareholders, and we'd love to make them happy.
Exactly. We're here to make them happy. But I am standing firm, and I am making sure that our promise to Omar is kept. The obelisk is still there. Dr. Connor Heffernan is still on it. He's not going anywhere. Wave over there. That's Connor. Say hey. We are still going to have guests on. I've actually currently in the process of organizing an episode on the philosophy, history, and science of the question, what is strength, that's going to be coming out. So iron culture remains, but it is now partnered and propped up by the soulless multinational corporation of Mass, which I'm a proud member of, so long as I keep getting paid.
All right, that is fantastic. Now, I feel like there is some need for some reintroductions here, right? So as we bring these two families together, it's really a marriage that we're celebrating tonight between iron culture and Mass office hours. Both of those families are very familiar with you and I, Helms. You're a regular on office hours. Obviously, you've been on, 299 of the 300 iron culture episodes. So people know enough about you. And I've been in the iron culture game for a minute now, so I think people know plenty about me. And I've been on almost every office hours episode. So we're covered. We're good. We're old news. But specifically for the iron culture crowd, I think it's probably a good idea to kind of reintroduce the good doctors, Mike Zourdos and Lauren Colenso-Semple. Obviously, you've both been on iron culture, but not as, we put you in the little smaller chair, a little bit lower, off to the side. You haven't been in the hosting chair. So at this point, we should probably reintroduce you. And Mike, why don't you tell some folks about your background, who you are, and what you stand for in life?
Yeah, first and foremost, I'm excited for that barn burner episode, What is Strength? I'm sure that'll be a quick one with some clear answers and some clear practical takeaways for the folks. Secondly, I actually suggested a third podcast instead of merging the two to put Trex to work a little bit more. So I lost on that one, but you can drop something in the comments if you think you should start a third one and bring these back. I wasn't in favor of this. But nonetheless, I am here, and I'm grateful to be here. So if you're not familiar with me, and you very well may not be, I'm often put in the short chair, not because Trex does that, just because, I am about the same height as my 8-year-old son. And I've been around this business for a little while now. One of the reviewers, obviously, in the Mass Research Review, started back in 2017, and honored to be with this team. And I've been a professor in exercise physiology for 12 and a half years now. I did my PhD at Florida State University. I graduated there in 2012 in exercise physiology. I was trained in part as a bench scientist, and adapted that research into a powerlifting dissertation. That's right. Helms just did the universal sign for lifting weights. If you've ever gone to a holiday party, somebody says, "Are you the guy that lifts weights?" And they either do a bench press or a dumbbell curl of some sort in the air, to which you nod your head and say, "Yes, that's me." And as I adapted that research into powerlifting performance, I got interested in a whole host of other things that was focusing on skeletal muscle. So I've done work related to strength, obviously, related to programming and periodization models, related to biomarkers of neuroprotection, related to exercise oncology, and then getting back lately to our bread and butter work with meta-regressions with some fantastic students on training to failure for hypertrophy and strength and volume for hypertrophy and strength in iron culture. Just had one of my phenomenal students on recently in Josh Pelland. But it's an honor to be here. I do that work still as a tenured professor at a university, and I am honored to be working with this crew in Mass and to be on iron culture today. So it's great. Hopefully I'll be around a bit, talk about these concepts, anything related to training, and mostly just being able to push for that third podcast so we can get Trex to work a little bit harder. He looks a little too rested to me today, but that's who I am, and thanks for having me to the original Iron Culture team.
Awesome. Yeah, go ahead. Go ahead.
Trex, I can't let him get away with not stating some specific accolades, such as squatting 500 pounds, squatting every single day for sometimes more than 3 months at a time in his career, to a 9.5 to 10 RPE, being the head coach of Training Revolution LLC, which has coached USAPL national champions, as well as multiple people who've represented at Worlds. In addition to coaching, I think, the successful Florida State powerlifting college team over multiple years.
Those are all true. Those are things, I'm not here to talk about myself, but if you're going to bring it up, Eric, I can go about this all day. So, we might want to clear some time here to talk about these facts. But on that, if you weren't familiar, you didn't mishear. I have at one point, I'd say just about 10 years ago now, maybe a little more, did perform a max back squat for, I believe, about 130 consecutive days. I can go back in the notes. I have that Excel file, and toward the end of that, it was twice a day. So it was quite a bit. These were toward a near max, and the quick summary of that is I got very, very strong. That strength wasn't really good for anything in life other than actually doing that movement of the squat. But it was an interesting experiment to do on myself. Enjoyed it. Those were back in the days when I was competing in powerlifting and doing that. So it was a great time in terms of not really having much else responsibility in my life. And so I was able to focus on this and pretty much this goal solely and do that. But I did do that. I have coached a lot of lifters that have won at USAPL Raw Nationals back in some time, other lifters that have taken home their country's world championship outside of the U.S. and have represented at World. So it's been an honor to coach those. It was an honor to compete in powerlifting for a number of years. Played collegiate sports. I now compete in some other exercise disciplines that the folks on Iron Culture might not want me to mention, so I won't do that. But I do have that robust practical applied background and was a strength and conditioning coach at the collegiate level before I got into my research and PhD. So one of the reasons, in all honesty, I've been a listener of Iron Culture for many years is, with all due respect, Trex, because of the culture episodes. Coming from a background of working in collegiate strength and conditioning and getting into it at a young age for sports performance, being around a lot of those old strength coaches in professional sports, did some consulting and went up to see the Philadelphia Eagles to give a presentation a few years back as well. It's been great to listen to those culture episodes and take those in. So I do look forward to listening to more of those as a consumer of Iron Culture, as well as somebody who will be appearing regularly now.
Good stuff. Now, Mike, something that Iron Culture folks aren't aware of is that a huge pillar of Mass office hours up to this point has been college football. It's probably the third most common topic, lifting, nutrition, then college football. Any comment on Florida State and Michigan this year? How are you feeling? Are you in a positive mental space right now?
Trex, it's in terms of Michigan, and I grew up a Michigan fan, so I'm 39 years old, meaning that when the Fab Five was there, and we're talking 89, 90, 91, right around this time, right? Michigan won national championship on that time in basketball, beat Seton Hall, and went to the Final Four again. When the Fab Five was there, I was a little kid, and they were the coolest guys in the world, and I became a huge Michigan fan, right? And to this day, I remain a Michigan fan. But after the national championship last year, with nothing, may I say, nothing nefarious going on.
No controversies.
All.
Yeah.
No controversy, nothing of that sort. Michigan can live off of that for a long, long time.
Yeah, you can coast a decade before people start getting on edge. Yeah.
I am just fine with Michigan having the season that they're having and, going 6-6 or whatever number of games they play now when teams in the Big Ten span the coast of Maryland and UCLA being in the same conference. Florida State, however, that's another story. I defended them last year because I think winning your games is more important than who somebody maybe kind of thinks is better. But they're not doing a great job of holding up that end of the bargain this year. And I'm just here for after this season when Florida State offers my man Coach Prime about $7 billion to come coach in Tallahassee, and he accepts. And then that's the only thing I'm going to care about. But as bad as they all do, Trex, it is hockey season now for me, and I need to focus on the Washington Capitals.
Yeah. Now, every time we talk about college football, Helms sometimes literally leaves or sinks in his chair. But Helms, one of these days, I'm going to bring you back in by talking about the impact of college football on strength and conditioning and iron culture in sport. Because there is an interesting story to be told there. It's pretty wild when you talk to college athletes and you say, like 50 years ago, nobody would touch a weight because everyone thought it would make you slow. And then college football really was kind of an early adopter sport that got people lifting. And only after you had all-American running backs lifting weights and running 4.4 40-yard dashes did people say, okay, I guess I'll let my sprinter do some weightlifting. I believe they'll be okay. So there is an interesting history there. Yeah.
Yeah. As you guys can all see, there was an intense contractual debate as to what topics could be covered in this merger. I lost that debate. My position was that football could only be discussed within the context of strength and conditioning for football, the football combine, or specific anecdotes that Trexler could drop about the size of running backs' biceps preventing them from holding a football. I really like that one.
Yeah.
I can tell that story multiple times, as many times as you'd like, about the genetics of football players, or how we've seen many football players become quite successful after the football career in powerlifting. That obviously did not go through, and we have allowed, although I have noted great dissatisfaction, discussion of both college and NFL football on Iron Culture, and I would like to officially apologize to everyone who's listening.
Well, there you go. Moving on, someone who will not be bringing up football, the good Dr. Lauren Colenso-Semple. She's firmly in the anti-football camp. But Lauren, your turn. Why don't you tell the good folks at home where you've been, what you're all about, and what you do?
What I'm not all about is college football nor the NFL, most importantly. I think I can just leave it there. I'm excited to be here, excited to be at the big kids table, as you put it. And although by the sound of your introduction, it sounded like Mike and I weren't necessarily your first choice, more just like the convenient backup plan. Nonetheless, I will take it. I have a PhD in muscle physiology from McMaster University, and I've done a lot of work on female sex hormones, and I was really interested in exploring, why female participants are underrepresented in the literature and what we need to do to start to close that gap, and what the scientific findings actually mean for women in their everyday lives, regardless of what physical activity you are engaging in. And I've been on the mass teams since last January, and excited to be here and contribute to some exciting discussions.
Yeah.
Trex, what is it with these folks being too humble to fully elucidate their impressive backgrounds? I don't know.
I don't know. It's to me, it kind of grinds my gears. It's that kind of false humility where people, I'm just, I guess technically I do have a PhD, and yeah, they won't They won't talk about their accomplishments, now that it's out on the table, it's why they weren't our first choice as Helms, and we talked about this at length.
Yeah. We need people who understand that narcissism is a feature, not a bug, in the current fitness industry. Being on social media and singing your own praises, you do that until people just start to believe your own hype, and that you believe it too, and then you believe your own BS, and that's when you ascend to greatness. That's just the way the fitness industry works. So I'm going to do a little bit of this for you, Lauren. I'm going to ask you some questions, and then I just want to hear your answers. What are some of the lab environments and internship environments that you've worked in the fitness industry with maybe some names that people might be familiar with?
I will try to step up the narcissism. Noted. I graduated summa cum laude from the University of Buffalo with a degree in psychology and nutrition. And then I worked as a personal trainer and group fitness instructor in New York City. And I volunteered in Dr. Brad Schoenfeld's lab. And that was my introduction into the world of kind of applied exercise science. I subsequently went to the University of South Florida, and I earned a master's degree under the supervision of Dr. Bill Campbell. Did some really cool work there, looking at high and low volume in trained women. And spoiler alert, there wasn't a big difference. And also collaborated with Trex on some interesting work looking at refeed strategies in bodybuilders. And I spent a summer at the University of California State University at Fullerton, working with Andy Galpin, doing some cool single muscle fiber type stuff, and also looking at fiber type distribution in Olympic weightlifters and sex differences therein.
I also have it on good authority with visual evidence that you have deadlifted multiple hundreds of pounds, specifically in front of American flags. And I'm assuming that's basically every single workout that you do. Is that an accurate representation of your training?
Although I am currently living in Canada, I am very, very proud to be an American, and a good lift always involves an American flag. Yeah.
You know what? I mean, that is one very positive change that we're going to have now that we don't have a Canadian host who has forced the maple leaf onto all of us. Mm-hmm. I don't know if people have noticed the history of iron culture is disproportionately dominated by Canadian guests over the years. And we just don't believe in discrimination. And we do believe in equal opportunity. And that is one positive change. I was able to push that over the line that we wouldn't have unequal Canadian representation anymore on the podcast, but I did have to concede the discussion to both Lauren and my own disgust, frankly, some of the points on college football and NFL. But thank you so much, Lauren. I appreciate you leaning into that narcissism a little bit, and you'll learn from the greats. That's what me and Trex are here for, and we'll get you up to speed eventually.
Sounds good.
Yeah. So, you mentioned, you worked with Schoenfeld and Bill Campbell, little time with Galpin, PhD in Stu Phillips' lab up there in Canada. So certainly you have been at the center of the fitness world for quite some time, kind of drifting around the periphery. Yes, Helms.
One amazing story that I do have to tell is, so Dr. Colenso-Semple has some very high standards. And you have to be quite notable and respected in the fitness industry for her to work with you, because she was looking around for where did she want to do her PhD. And she actually had a call with one at the time, not a senior research fellow, but just a lowly regular research fellow at Auckland University of Technology at the Sprins Labs, which is a pretty well notable lab, and it's in the top 25 or top 50 rankings. But she had a consultation with one Dr. Eric Helms, time research fellow, not senior research fellow. Maybe that would have put her over the edge. And she said, thanks, but no thanks. I'm going to go do my PhD in a real lab. And shout out to Stu Phillips. That's all I got to say.
Good decision.
Well, I think, Helms, you alluded to this joke and it kind of floated off into the ether, but I think that there are two very different views about what bench science is. And some people might view that as doing advanced, molecular work, understanding really important mechanisms of how human biology works, how this machine functions, kind of breaking down new barriers as it pertains to scientific inquiry. And for some people, it's a bench press. And I think, Lauren, I don't want to put words in your mouth, but it sounds like that was kind of the decision that was made.
That was a factor, yes.
Yeah.
She asked if I did bench science, and I said that was literally 1/3 of my PhD. And she looked at me a little odd, and then she said, "Oh, the connection's going bad," and she hung up. So that was the end of that conversation.
That makes sense.
The second third was counting. What was the third third?
No, it was squat, bench, and deadlift. That was my PhD.
I don't know. I saw you doing a lot of counting when you were collecting your data. A lot of, what's your RPE? 7? Are you sure? You sure it wasn't, 8? And they would usually say, no, it was 7.
Yeah.
It was about the extent of it.
Helms, honestly, he could have picked up like a minor in integers, as in the math department. Like, no one knows integers below 25 to a better extent or with more expertise than Eric Helms.
Yeah.
Only whole numbers.
25 is actually very, very kind there, because when I saw the Borg 6 to 20 scale, I went, no. We got to rethink this. Too big, too much.
Yeah.
And we restricted that to 10.
Well, yeah, because the lab you were in, you couldn't take off your socks. And so anything above 10 was going to be a problem.
Yeah. I mean, seriously, when you're doing real bench science with the bench press, you don't put a collar on, things slip off, and you've got some major liability issues on your hands for those toesies.
Yeah. All right. Now, we poke fun, but of course, the great Dr. Eric Helms, an esteemed scientist, excellent applied work happening down in New Zealand. And you've been really, you've been picking up the output over the last several years. I mean, you guys have been doing some really cool work and cracking out a lot of papers out in New Zealand, which has been, I wish we could cover them more en masse. Obviously, there's only so much we can do. We can, cite them in other work, but yeah, it's. I saw you perked up a little bit when Lauren mentioned our collaboration on bodybuilders, and that's certainly a space where you've been absolutely crushing it over the years. Do you have any bodybuilder stuff going on now, by the way?
I do, yeah. Actually, to be serious for a moment, I am really privileged and honored to be in the position I am at AUT. It's what literally kept me in New Zealand, was the amazing lab environment at Sprins and the mentorship I got, which ironically actually included Dr. Mike Zourdos, who was my tertiary supervisor, and I did one of my studies for my PhD actually at FAU. And I met great folks there who eventually came over to do their PhD with me. So, for example, now Dr. Colby Souza, who's graduating in December, did his master's with Dr. Z right here, and he did his PhD with me. And we have a really cool group of people, a mixture of mostly powerlifters and bodybuilders who are interested in studying their sport. And that's the way I really view myself, is a sports scientist. I actually do get my PhD technically in sport and exercise. And, a lot of people know me for my nutrition knowledge or my training knowledge, but I always view it through the lens of strength and physique sport. So right now we've got a competitive bodybuilder from Japan. One day, Dr. Takehiro Itagaki, who's specifically looking at what factors seem to be common between exercises that are better for hypertrophy. And we're going to be looking at some proxy measurements of hypertrophy, comparing EMG, high-density EMG signals, muscle oxygenation, as well as sensation and perception of stretch, pump, and acute changes in ultrasound muscle thickness in various exercises, and using within participant designs to see whether those are actually predictive of longitudinal hypertrophy when we compare exercises that we think fit some of the quote-unquote checklists of what makes an exercise better. So that's exciting stuff, but I've also got a lot of cool powerlifting research going on as well. Christian, one of my PhD students, he's part of the Danish powerlifting team, and he's looking at specificity, specifically, pun intended, in exercise selection and how that impacts strength development. My former PhD student who has been on MASS, Dr. Alyssa Joy Spence, she is now my right-hand woman. She's got a full-time lecturing position at AUT, and she is still investigating the influence of stretching on strength and how it impacts powerlifting performance, which was her PhD topic. And Kedrick Kwan, who's arguably the most sought-after nutritionist in powerlifting right now, he is within a month or two of submitting his thesis, where he looked at different weight-cutting strategies and the acute impact on strength and psychology, which is going to directly inform how people actually make weight in the 2-hour IPF kind of style. So, and that's just a couple of my students. There have been others who we've had on. Dr. Lauren Colenso-Semple was on with Kim Santa Barbara, and they touched on both kind of the molecular side for Lauren and then the applied side with Kim on how to mitigate some of the PMS symptoms that might impact female lifters. So yeah, I honestly am so privileged to do what I do and get to kind of pay it forward and pass the baton because I'm getting to meet people who are in a similar position to me when I was 12 years ago coming out to New Zealand to do my second master's and PhD. And it's something I'm very proud of, to be honest.
Nice. And as your work continues to get more and more and more applied, I am sprinting in the other direction. I haven't really talked about my research much on podcasts lately, but I've really found a bit of a sweet spot. I'm doing a lot of research on rural populations, and I'm enjoying it quite a lot. It's a very cool, it's not directly applicable to your next bodybuilding prep, but there's a lot of really fascinating topics that we can look at because I do a lot of work with rural populations in the United States where there's a lot of obesity and cardiometabolic disease. And we have an extended network of people that we collaborate with who are doing rural research really in all corners of the world, but primarily in subsistence, I always stumble over that word, subsistence populations. So a lot of hunter-gatherer groups, pastoralists, very, very small-scale farmers who really don't have a lot of market access. And obviously, being in Herman Pontzer's lab, we do a lot of doubly labeled water research, but it's been really cool to look at some extremes of physical activity levels, energy expenditure levels, looking at extremes of water turnover and kind of addressing really important questions of how we quantify and make ends meet in terms of water turnover in areas where, you're averaging 25,000 steps a day. It's super, super hot near the equator, and it's a pretty long walk to get any water. And you pretty much go get water once for the day. But yeah, it's been a huge change in the type of research I do, but it's still, just kind of figuring out how this whole machine works. Being in a evolutionary anthropology department has kind of broadened my scope of how I look at physiology and how we can actually manipulate it. So the studies themselves, not very applied. They're not going to, we're not finding a new powerlifting approach that's going to, boost your bench press necessarily. But I think folks who have been members of the mass community for a while have seen that it's a fun little way to look at some new topics related to health and longevity. And one of the things you have to grant, Helms, you must agree, you got to be alive to be the best bodybuilder you can.
I A, agree, and B, you're talking about step counts and cutting water. I'm on board. We're basically right back in my lab as well.
Big time. All right. So, Lauren, we talked a little bit about bench science, and it'd be interesting to see you and Mike go have you guys fight each other about who has the most legitimate bench science chops. We'd have to dig back into the, who did more years and more different types of scientific methods. But Mike, you look like you're about to...
Lauren does.
Okay. So, Lauren, you are our resident molecular physiology expert. You do all sorts of slicing and dicing muscle tissue, which I know Helms is categorically against on a spiritual level. But you've been known to take a biopsy out of a quadriceps muscle group from time to time. You've spent more time around a microscope than anyone else in the mass team, that's for sure. And for this episode, you mentioned that you were going to talk a little bit about satellite cells and kind of how their role, the way we talk about them has kind of changed over the years. And I don't know where you're going to go with this. I'm in on the surprise as well, or I'm not in on the surprise, but back in the day, satellite cells were the talk of the town. People talked about how they were, highly predictive of this and that. There was all sorts of debates about how much plasticity we have in terms of gaining them and then losing them after they've been gained. So there's been a lot of conversation about satellite cells and their relevance. Comes up a lot when people talk about anabolics, of course. So Lauren, satellite cells, the floor is yours. It probably makes sense to start out with what they are, why people care about them in the first place, and how that conversation has changed over the years.
Sure. Yeah, so satellite cells are muscle stem cells. So they reside outside the muscle fiber in what we'd call the basal lamina. And they have their own kind of niche, and they are typically, we would say, quiescent state. It's an inactive state, and you can measure that under a microscope. You can kind of measure each state by staining for a particular marker. And for a long time, we've known that satellite cells are involved in repair. When you look at damage, and we initially discovered this in the context of severe injury, accident, surgery, not exercise-induced muscle damage, but they are involved in repair and in renewal and in just kind of maintaining the extracellular matrix as well. So they do kind of a cleanup, because when there is damage present, there are reactive oxygen species that are released, and you need something to kind of go in, the cleaning crew, and make sure that all of that, it doesn't stick around, because that can lead to a lot of excessive inflammation, which is not great. You can get fibroblasts that stick around, and then if you're getting more and more buildup in that extracellular matrix, not only is it not good for growth, there's a whole other host of downstream effects that can be pretty negative. So, as I said, we've known that, and no one kind of disputes that they are certainly involved in that cleanup, that repair from damage. But in the late 60s, so this is a bit of a history lesson, since you like a history lesson. In the late 60s, there were some doctors caring for a 9-year-old girl with a very rare genetic disease. And they noticed that she had unusually large muscles. And this was something that they really wanted to investigate. And she was a great sport. I assume her parents were too. She let them take muscle biopsies. And they're trying to figure out, this must be a side effect of this very rare genetic disease. And they took sections of the muscle from the biopsy and did some staining and did some microscope work. And what they found was, wow, in every slice, we're seeing a lot of satellite cells. And they aren't outside the fiber in their niche in the basal lamina. They are in the fiber really close to nuclei. And we're seeing this over and over and over again. And so this was the first kind of hypothesis generator that perhaps satellite cells are involved in muscle hypertrophy. So fast forward for the next couple decades, and people started looking at this work simultaneously in rodents and humans. And that's really interesting, because often when we see something or potential mechanism, find something new that we want to explore further, it almost always starts in cell culture and then goes to an animal model, and then maybe not progresses to a human clinical trial. But this is interesting because like I said, this kind of hypothesis was originally generated looking at human tissue. But then, of course, there are limitations in terms of what you can identify and analyze, and the types of experiments you can design in humans versus rodent models. So they kind of took off in simultaneously but different directions. And as you mentioned, Trex, there are some studies from the early 2000s looking at, they did really similar analyses actually, doing the same kind of staining and kind of satellite cell counting, either pre and post training or acutely after kind of a damaging bout of exercise, and then looking at the satellite cell response in the subsequent 24, 48, 72 hours. And there was a lot of splash around some of those papers because they said things like, hey, these high responders, the people who are getting the biggest from a 12-week training program, had more satellite cells pre-training. Or these extreme responders had more nuclei per fiber. And so that led to the potential conclusion that, a higher responder has more satellite cells, or the number of satellite cells is predictive of your hypertrophic potential. Now, as I said, it's more of an association, right? So we can't say that contributed to hypertrophy or that is why they got bigger, because as we know, given what we know and what we don't know about the mechanisms of hypertrophy, it's much more complicated than that. You really can never just boil it down to one single mechanism. And certainly simplifying it to say, it must just be about the satellite cells would be way, way too simple. You're not looking at the bigger picture. So around this time, some of the rodent people said, hey, let's look at it from a truly mechanistic perspective and design a model where we try to remove the satellite cells and we look at what happens in the absence of satellite cells. So the early models used an irradiation technique to kind of kill the satellite cells. Very aggressive. The problem is, so you do that, the satellite cells are gone, but then you proceed with the rest of your experiment, which is the synergist ablation model, meaning you are removing the gastroc and the soleus, and then you're waiting for compensatory hypertrophy of the plantaris. And what they discovered was, hey, that irradiation was so aggressive that we don't see any hypertrophy for up to 4 months, simply because you just destroyed this muscle. So that's not going to work. So the next step was developing a gentler model, if you will, and that is through a special strain of rodent that you could essentially delete the satellite cells without causing all of that damage through more of a selective mechanism, and then again perform the same surgery to the synergist ablation, which is actually very aggressive, and I'll get back to that. But anyway,
don't worry, we've already fallen through with the PETA sponsorship, so just it is what it is. That happened on the last episode of Office Hours when I said tragically crabs in a barrel. Got the phone call, that was done. So it is what it is. You go ahead, Senator. Right. Carry on.
Okay. Yes. So there were 2 studies done with this model within a couple of years from each other, where they looked at the question: is the absence of satellite cells going to blunt hypertrophy, or do we get hypertrophy anyway? Because that answers the question, right? One lab group said, absolutely not. There was no hypertrophy. Clearly, we need satellite cells in order to see growth. The other lab said, hey, look, we saw growth anyway. Satellite cells are unnecessary. They're not contributing to the growth response. And this is everyone kind of scratching their heads. At the time, they did a lot of responding to each other's papers and debate. And ultimately, the third group has to come in and say, what's going on here? I'm going to replicate this. And interestingly, what it came down to was the age of the rodents. So one lab group had done this in 4-month-old rodents, and the other lab group had done this with 2-month-old rodents. doesn't sound like a big deal, but actually a 2-month-old rodent is still maturing, still growing, still developing. A 4-month-old rodent is an adult, is mature. And so sort of by accident, they realized, hey, satellite cells are really important during the postnatal phase for growth, for development, for maturation. And so that's why they saw that it blunted hypertrophy in those younger mice. But in the adult mice, it didn't matter. They still were able to grow muscle without satellite cells. So that was an interesting finding, and it's a great example because while those seem to be conflicting, they actually weren't. It came down to the nuance of, their population and something as small as that age difference. So meanwhile, in the human camp, there's a study looking at powerlifters using anabolic steroids. And they looked at a variety of markers in their muscle tissue through doing biopsies, and they looked at people who had been taking steroids and people who hadn't, and they described the steroid users as testosterone among other anabolic agents. It was just a kind of catch-all, but they saw yes, they have much larger fibers, they have more myonuclei per fiber, and wondering, hey, perhaps all these satellite cells are necessary to maintain these massive fibers. Is it that? But the conclusion of that was, hey, well, anabolic steroids are really accelerating the contribution of satellite cells, and B, these big guys have way more satellite cells, and so perhaps this is contributing to hypertrophy. So it's kind of this back and forth, but on the human side, we're really looking at a lot of correlation, association, this is the relationship we're seeing, whereas on the rodent side, it's a extreme model that's really not that translatable to any kind of human muscle circumstance. But I think through all of this, although there's still some controversy here and there's still a lot we don't know about satellite cells, they're really cool. They do a lot of communication with endothelial cells, for example. They may have roles in muscle that we don't even know about, and so there's a lot more work to be done there. But I think we are at a point now where both sort of sides would tend to agree that satellite cells are probably necessary for growth, for development, for maturation. They probably aren't necessary for short-term hypertrophy in adults. So let's say your average training study, or in a rodent study, your average 2-4-week rodent study. However, in order to maximize your hypertrophic potential or maintain a large amount of muscle that you have built, they probably are required. And certainly they are always going to be necessary for that long-term tissue health, function, and repair from any kind of damage. So I like this story because I think, of course, there's controversy all the time in the scientific community, in the fitness industry. And this is a really good reminder that, science takes a long time to answer a question. I'm talking about decades of work here and a lot of lab groups and a lot of studies. But along the way, they discovered more nuance to the question and other things that they hadn't even considered. And I think that at times when we're in this state of controversy, we really just want the answer, and we think in very black and white. It must be this or it must be that. And this is a really great example that often the kind of truth lies somewhere in between. There's a lot more nuance, and it takes a lot of time to answer really complex questions.
Now, Lauren, I think you did a great job kind of summarizing and taking us through that historical tale. I did have Two questions. The first of all, these rodent people you mentioned, are they still among us?
The rodents are not. The scientists are.
Okay, so the rodent people are out there, so we'll keep an eye out for them. Mm-hmm. The other thing I wanted to ask was, we look at these situations where satellite cells, it seems like they are playing some type of role. We're talking about, times of growth and maturation, and also retrospectively, it seems like, perhaps anabolics are having some role in elevation there. Would it be fair to suggest that, in a way, when you decide, hey, I'm going to be a power lifter on anabolics, that you're kind of going through another, pretty substantial change in, growth and development? It's like a different scale of growth, right? It's almost like puberty 2.0 when you decide I'm going to go on super high doses of exogenous hormones. Do you think that that's a fair connection to be drawn there?
I think that's really interesting that you would say that, because when they were looking at some of the growth factors expressed in those muscle that they took from the anabolic steroid users, they did comment that it was youth-like, and so it was exactly as you said, that it did kind of mimic a large-scale growth rate that you would not otherwise see as an adult.
I really actually like where this conversation is going, because for those who aren't aware, and this is something that, Lauren, you talked about in one of your resistance training papers, the relative increases in muscle size, when you look at them as a proportion or a percentage, are very similar between men and women in response to resistance training. And as we all know, there are drastically different endogenous levels of circulating testosterone in the two. Hold that in your mind while you also consider this. When we look at training responsiveness, how much does someone grow from resistance training? There's really no relationship, which makes sense based upon these sex differences, between your baseline level of testosterone and your quote-unquote growth potential. However, there are slight differences when you look at some of the research on hormone replacement therapy, hypogonadal men, with baseline levels of muscle mass and testosterone. And of course, there is probably a relationship there between the sexes as to, their baseline level of muscle mass that's related to that as well. And that's something that's being discussed with some of the issues of people who are transgender competing in sport and trying to figure out that and untangle that whole controversy. So I've sometimes wondered if the use of PEDs and anabolic hormones is almost just kind of elevating your baseline and making you more muscular sort of everywhere, and also elevating the potential of the muscle groups you train. And I think that's one of the challenges of this line of research, where we can't do controlled trials. For ethical reasons, we can't have a group purposely take anabolic steroids, another group take a placebo control, and then see what happens. And the little bit of research we do have in areas where that was a little more acceptable are much more in the range of what we would consider testosterone replacement therapy, rather than mimicking the polypharmacy, very high dosages that are used in bodybuilding and powerlifting. So I find that really fascinating, because right now it's very difficult to know whether some of that satellite cell change that we see in anabolic users is due to the level of muscle mass they've attained, or is it actually caused by the use of the hormones? And I think that is one of those critical pieces to this puzzle that we're still trying to uncover.
Lauren, I have a couple questions for you that I've been jotting down here. So one, and not to get too much into this, but I was interested in, so when satellite cells are activated, for the differentiation portion of that to occur, right, we have these myogenic regulatory factors, right? So we have, MyoD, myogenin, PAX7. So these are, for anyone listening, these are essentially, and Lauren can give you a better definition if I'm not, but essentially like little proteins that are expressed, and the greater expression of them is going to allow for the differentiation, not just the proliferation of satellite cells. And so satellite cells are stem cells, so stem cells can become, other things, other types of cells. So it's facilitating repair. So I was wondering if you could talk a little bit about, because you mentioned the difference in the age of the rodents, and that is quite a big difference. A little bit about with aging, does satellite cell number change? And if so, does that have anything to do with kind of the recovery process? You have other proteins like myostatin, I believe, that would be increased with age that might downregulate some of these myogenic regulatory factors that then might cause the kind of regeneration or repair process to be to be negatively affected or impaired as someone ages. So with aging, what's happening with satellite cells, and how are these other proteins that essentially help facilitate the satellite cell repair process affected? I'm familiar with a lot of the papers you're talking about originally, which came from the UAB lab. My advisor was a co-author on many of those papers. He was a postdoc there at the time, so I became very familiar with this. And this was in 2008 when I started getting into research. So that was my introduction into it, was essentially, got to get a nuclei from satellite cells to support this bigger domain. So, but with age, is satellite cell number affected? And then how are these other proteins, if it is affecting that satellite cell kind of differentiation and repair? And what can people expect with age?
There's not enough good work on this topic because it's, in order to really look at the satellite cell response, you need to induce damage and then look at it acutely in order to say this is how they are behaving, right? So you can say, oh, let's just measure how many you have, but that doesn't really tell you anything about the activity. And so I don't believe that this type of study has been done, but it has in younger people. It basically do a ton of really damaging eccentric contractions and biopsy, and then biopsy 24 hours later, biopsy 48 hours later, biopsy 72 hours later, biopsy 96 hours later, and that should be the time course of that activation differentiation. And I'm not aware of a paper that has done that in older individuals. That said, myostatin, when take in larger quantities, like not necessarily what's produced naturally, that is clearly going to downregulate satellite cell number and diminish the response, as you said. There are some training studies in older people that looked at satellite cells before and after training. It looked like numbers still did increase with training. There were sex differences, though. And so there's something to be said potentially for the role of estrogen and the regulatory role there in maintaining the satellite cell niche. And there appear to be estrogen receptors on satellite cells. And so it's something that really should be further explored and hasn't really been explored much in humans. But I think it's an appropriate hypothesis that in perimenopause, when you start getting downregulation of the ovarian hormones, that those are contributing to the loss of muscle mass with age, particularly in women.
Yeah, I think if I recall, one of the sex difference studies was also one of the UAB studies. It was 3 days a week, I think, of lower body exercise when they saw those sex differences. I have one other question for you. So this is a little bit more of a kind of a practical question, I think some listeners would probably be interested in. So there's been this big discussion, I don't know, maybe a decade or so now, and your advisor published a paper, I think a senior author, that was really important to this, that we reviewed in Mass back in 2017-ish, 2016, talking about if muscle damage is related or a causative factor in muscle growth. And so if we go with kind of, what you're saying earlier, that when an individual is maturing, satellite cells are going to be important for growth, but once they're an adult, hey, maybe not such a big deal. But we do know that satellite cells are activated and they're very important in the repair process. And I like that you pointed out, initially, it wasn't from exercise-induced damage, it's due to trauma, right? So anytime there's trauma, anytime there's damage, we tend to only think of it in terms of lifting weights. Satellite cells are going to be activated, they're going to repair that damage. So is that evidence someone can use and say, hey, muscle damage isn't causative or isn't related to muscle growth? You're going to get the satellite cell activation and repair, but that clearly, because of any trauma that's induced, you're not seeing growth from that. Is that an argument someone can use and say, hey, satellite cells aren't necessarily a big deal for growth in adults, and muscle damage isn't a causative factor in growth? Are those appropriate arguments to use that data?
I think the argument some would make is you're seeing damage for the first 8 or 12 weeks, and therefore you're not seeing detectable growth. I have heard that argument made. I would say when we think about if it is going to contribute to hypertrophy, you can look to the non-hypertrophic literature, right? So you look at HIIT training, you can look at aerobic exercise training, and you still see satellite cell response in those circumstances, and you don't see growth. So clearly satellite cells are playing a role that is not inextricably linked to hypertrophy, because we're seeing it in those other contexts. But as far as what Helms said before, right? Can you say, well, we see the satellite cell response and we see growth, so they must be related? Maybe, maybe not, because if you can have growth and you can have satellite cell response because of the damage, then perhaps they're actually both present, but they're not working together. They're working against each other. So both of those are possible.
Yeah. The one thing, last comment before we kick it to Helms here, is the first thing that I wrote down on my note sheet here when I was coming up with some questions was, we know so little. And if anybody out there thinks that hypertrophy is fully understood, we are so far from understanding fully how hypertrophy occurs, at least mechanistically. So enjoyed listening to that. But sorry about that intrusion there, Eric.
No, actually, it leads perfectly what I was going to say, and I was going to kick this to you, Mike, because you hinted at it, and I think it'll really serve to complete the circle for people's understanding of this topic and why it's relevant. You hinted at myonuclear domain theory, and I think one area that's, I believe, still an open question is not whether or not we need satellite cells for muscle growth, because it seems we probably don't, but again, going back to, is it the muscle growth you can achieve over a relatively short period with anabolic steroids, or is the use of them that results in these higher levels of myonuclei that were donated from satellite cells? Is it perhaps that once you reach a certain threshold of size, independent of whether you used anabolic steroids to get there or not, that's when satellite cells do become important? And I have seen some speculate to say, listen, if you want to get bigger over the course of an 8-week, 12-week study like we have in typical resistance training studies, especially in untrained individuals, yeah, satellite cells, not important. But if you're trying to become as big as you possibly can, now all of a sudden we're pushing the limits of what I hope you can explain to us, myonuclear domain theory. So we need more satellite cells to come to the party to donate their nuclei to become myonuclei. We can govern more area. And it's surpassing these thresholds, and that therefore, maybe because of what we see in damage, it's going to require some pretty extreme training. This is where I think that the tenuous link is sometimes made, where, hey, it's that the tension that we produce in training is really, really high. If it involves eccentric contractions, it causes damage. There's fiber splitting, and, that results in satellite cell activation. And it is that type of training that is necessary to break through these advanced plateaus. I've heard that claimed. And it's based upon these overlapping and tenuous, but potentially true, claims about the role of damage as it relates to hypertrophy, the role of satellite cells in damage, but maybe also hypertrophy, and also some of the basic tenets and assumptions behind myonuclear domain theory. So I was wondering, and I'm sure everyone can chime on this, not just you, Mike. I'm sure Lauren has some thoughts, but I would love to hear kind of your thoughts on those layered assumptions and whether you think they could be true or whether there's some missing pieces.
So I wrote down one word here while you were talking, and I'm going to keep that a secret now. Just for a little bit, I want to build up the suspense. I know it's just kind of my first episode here, but I want to start things off strong, and I want to make sure that people are kept waiting just a little bit, and then I'll reveal that word and talk about if your theory of really hard training can do this thing that we're talking about. And the spoiler is that I don't know, and then I'm going to ask for Lauren's opinion. But in terms of myonuclear domain theory or myonuclear addition, right? So the thought is, and the way this was taught, years ago was, you'd show, just to show a slide, an oval of a muscle fiber, and there's a nuclei in it. And then the muscle is going to grow, and there's initially going to be muscle protein synthesis, and that will cause muscle to grow. And then muscle is going to reach a certain point. I'm avoiding Trex using my hands to show this because I'm going to get chastised by you that the podcast feed listeners won't see it, so I'm not doing it. But like Ricky Bobby, I don't know what to do with my hands right now.
This guy,
and so
for folks at home, the first 35 podcast episodes he would say, so you want to go from here to here to here, and he's just using pure hand signals. And I'm going, Mike, it is an audio medium. Please restrict your hand signals.
But two things. One, it helps me explain. And two, that's how I get Skype to show fireworks when I am doing these things. And I haven't seen you get fireworks or any thumbs up or likes pop up on your screen. So why don't you just leave me be?
Because I'm a trained
to get
speaker.
The accolades.
I'm like a politician. I do the perfect thumb buried in the index finger. Yes, I could do the accordion like Lauren just did, but you gotta, I'm podium trained. That's all I'm saying.
There's lots of people to choose from, and you get the bullet points. That's another good one. When you do the index finger, you got to get, there you go, right there. So myonuclear domain theory, myonuclear addition, you have that oval muscle fiber, let's say, on PowerPoint slides, somebody's showing you, there's a nuclei. You have muscle protein synthesis, muscle's going to grow. It grows to a certain point, the theory goes, Helms, and at that point, when you say myonuclear domain theory, it can't support a bigger domain without an additional nuclei. Where does that nuclei come from? Satellite cells are proliferated, they're activated, and then they're differentiated, and that nuclei is essentially dropped into that muscle fiber. And now we have an additional nuclei. And the muscle can only grow, then it's going to grow more. And now we're going to need more nuclei at a certain point to support a bigger domain. Not a lot of nuclei, I just saw right there. And so I'm going to be here a lot, folks, so get used to it. There's going to be a lot of these dynamite drop-ins. And so,
but if I may, again, you just made a joke about Helms flexing his muscle, and no one felt inclined to suggest that that's what the joke was.
Don't put that on me. He's the one that's using the visuals out here while I'm trying to have my discussion, and I tried to keep it together. I really did.
Yeah.
I really did. I'm doing my best. And then he comes in here with that.
Right, but when two people mess up, it's not that they both become blameless. They share that blame. So I don't see why you're trying to throw Helms under the bus. That doesn't absolve you.
I'll take a third of the responsibility.
Fair enough.
I'm not going to go, I'll take a third of the responsibility. So that's myonuclear domain theory. So when we talk about hard training, and if hard training can induce that, and if a lot of muscle damage can induce that, practically when we're talking about training, just to go this route for 1 second, I would view muscle damage more as a byproduct of what's happening, not the goal, not what you're looking for. It's muscle damage is going to happen. And as you, let's say, hey, I need to progress volume a little bit, right? I read Mr. Pellin's new preprint, and I say, hey, I need to increase my volume a little bit out there. I'm going to do that. You might induce some more muscle damage. If there's a new stimuli, whether it's more volume, whether it's a new exercise, whatever it is, that's a byproduct of what you're getting. And you may see some more growth from that, but that doesn't mean, as Lauren noted, it's from that muscle damage. It's probably from that new stimuli, whatever it may be. Your body's adapting to that, and you're getting that byproduct. When I think of really hard training, and this is what I want to get Lauren's opinion on. So we know that as we get bigger, the rate of growth is going to be attenuated, right? You're not going to see those beginner gains, those novice gains forever. If you could, it would be amazing. We can all think back to that greatest time in our life, those first 6 months, that year of training. And wow, it just doesn't get better than that. Every day, your shirt is fitting a little bit tighter. You walk out in public, you feel a little bit more confident, and it's just the most wonderful time. So to continue to get past that, when we talk about hard training, the thing that was thrown out there when I was first learning about this topic back, 16 years ago now, was if you train so hard, you could have two fibers split, or a fiber split, or you could have two satellite cells potentially combine with each other to create a new fiber. And that's called hyperplasia. Now, that's the thought process. And is that something that occurs? I know we have a little bit of newer data on that now, and we still have some discussion around this. Lauren, where are you on this as our resident expert? And I can explain why Lauren's bench training is greater than mine. There was a room where we would do this, the animal surgeries. I was down on the end of that room, and I was removing the bone from the animals for another lab that wanted to look at the bone. And when I finally moved my way down to do some surgeries, that's only because about 3 people were sick that day. And this is a true story. And my advisor, it's like when your starters are out, they're all injured, and your starters looking, maybe it's a basketball team. Maybe we'll just play with 4. Maybe we just won't put somebody else in. He decided to move me down. So eventually I got down there and to the big boy part of the lab. But for Lauren on that hyperplasia theory, saying, hey, we're training really hard. We need to get past this sticking point for growth. Our satellite cells combining with each other to create more fibers. Our fibers splitting to increase the number of muscle fibers that we have, which is the definition of hyperplasia. Not just grow, but increase the number. Is that something that occurs? And if it does occur, is it occurring by those mechanisms I just explained?
We definitely don't have sufficient evidence in humans to say that hyperplasia is occurring. There is evidence that it happens in other species, but I don't think there's enough evidence to confidently say that in humans. And I would say if that were happening regularly, when we looked at these populations of these, really huge guys, really strong guys, people on anabolics, all of that, we would see not that they had larger fibers, but they had way more fibers, and that would be indicative that perhaps that was happening. But what we know about protein synthesis is that we're constantly regulating transcription, translation. So when we talk about translational capacity, or the ability to build new proteins at a specific rate that allows for protein synthesis to exceed the rate of protein breakdown, and therefore we grow, the donation of the nucleus from the satellite cell allows that translational capacity to expand. But as you said, clearly that's not just going to keep going on and on and on and on. And so it's also it's an expensive process energetically for the body that you have to wonder at what point do you say we're going to prioritize elsewhere. It's you being more muscular is not the number one priority.
I saw Eric just get pretty upset when he said that last point.
Face
I think it did. One thing on that as a general research note, and I would imagine, my guess is that there'd be agreement in this online room here, but is that if something like that, we haven't been able to detect it, and that hyperplasia is quite difficult to test, but if we haven't been able to detect it, then if it does exist, its contribution to growth is probably very little. In that when we test things, if say, hey, we can't say confidently this thing doesn't exist, right? And I'm not saying that that's the case with hyperplasia or whether it contributes a lot or not, but in general, in research, hey, we can't say this thing doesn't exist. What we're saying is we haven't detected it. And if we do robust experiments with really large sample sizes and we haven't detected it, we can't say, hey, it doesn't happen. But what we might say is, if it does happen, which would be really cool to see, its contribution to this thing maybe isn't that much, right? Maybe this other thing we have to explain, it explains way more. So I don't know if we think that's the case here, but I do see that in other facets of research where, hey, I don't want to say this thing occurs or doesn't occur, but if it does occur, we haven't been able to detect it, so maybe it's not that big of a contributor.
I hesitate to tackle this because I think it could turn into another 20, 30-minute discussion, because I probably fall on the side of, I think hyperplasia probably does happen in humans, and that it might be a bigger contribution than it's been given credit for, and it's mostly a methodological issue. Like we mentioned, we really can't do study designs that in the same way we have with animals to demonstrate it. But yeah, I think it's one of those things where anytime we're all speculating, it's because we don't have the data, and we can't have the data in the way we would really like it. But I think there's some really interesting comparisons of muscles in cadavers that have been used more or less. There's some really interesting comparisons between, like you said, cross-sectional comparisons of actually anabolic users versus non-users. And there are some studies indicating a greater fiber number. And I don't know, I have a tough time thinking that in other mammals, with sometimes not very extreme protocols, like people love to talk about the extreme stretching avian models where we do see hyperplasia, but there's also some basic training stuff, where they actually, interestingly enough, trained cats to lift their paw for food while weighting it, which kind of just looks like far from failure resistance training, where we're seeing hyperplasia in cats. Now, obviously, we aren't cats, we're not birds, so it could be just a unique facet of other mammals, and they are obviously in many ways just far better adapted physically than humans are, because of just our selection and the way we've gotten to survive to today. But I would actually be surprised if hyperplasia was as a non-phenomenon in humans, and I would be slightly surprised if it didn't contribute to some degree over the entire time course of a very serious lifter, drug-free or otherwise. If they have a propensity to grow, that is, that's just my personal opinion, but I think we probably should restrict an interest of time going down that rabbit hole, no pun intended.
Now, I will acknowledge, I do tend to fall a little more on the Helms side of this really fierce debate, in the sense that I was taught as an undergraduate student that humans do a small degree of hyperplasia, that has been observed. Again, this is my undergraduate education, and I literally never bothered to look into that or fact check it or verify it. But that teaching was largely focused on cadaver studies, looking at, for example, dominant versus non-dominant arm or dominant versus non-dominant leg, and finding within-person differences in fiber count. But I was in no place to review the methods of those papers critically, nor did I have the inclination. But having said that, I very dispassionately agree with the general take Helms put out there. I have never bothered to look into it. I wouldn't be the first person who was led astray by an undergraduate physiology lecture. But having said all that, Helms, let's say that you're right. Would that, and I'm not trying to get you here, I'm curious, do you think that has any bearing on the way you would advise someone to train for hypertrophy? If specifically because of this existence of potentially of hyperplasia? Like, do you think it fills a gap in how we might approach training practically that is not already covered by other areas of research or other physiological explanations?
Great question. The answer is no, and I'll explain why for the listener. Let's say this is a regular part and parcel 10 to 20% contribution to hypertrophy at a certain point of a certain intensity in trained lifters. Let's say that's true. So recent study that I was a part of by Ruffalo and colleagues, where we had them do it within participant design, 0 RIR, momentary failure, leg press, leg extension, and highly trained lifters on one leg, other legs training to a 1 to 2 RIR, pretty similar growth in the quads in both, 6% rough increase in measures of hypertrophy over this training study. I think it was 10 weeks. Let's say 20% of that growth was hyperplasia induced or contributed to it. Okay, so that means that almost every time we observe hypertrophy in trained lifters, it's just kind of what's happening. It's a description of how, not what to do, how it happens. It's. I would think it would be similar to some of our over-focus on hormonal adaptations to training, or the hormonal mechanisms behind fat loss or energy balance that can really lead you astray if you get too focused on the signaling and the messengers that are going on rather than the what do we actually do practically. So it's an interesting theoretical debate, but I 100% agree. If it is regularly occurring, and I am right, then mission accomplished, we're already doing it. You're getting the hyperplasia. Congratulations.
Yeah, and I do want to defend my honor very quickly. The reason that I did not fact check this professor is I was super lucky, and my undergrad physiology courses were actually taught in the medical school, and they were taught by a team of instructors. So basically, when we did our unit on kidney physiology, a kidney specialist came and talked to us. It taught the whole unit. So every kind of physiological system was taught by someone who specialized just in that system. And our muscle physiology instructor was so cool. They were talking to us about the experiments they were doing with myostatin inhibition and showing us all their experimental findings in rodents and even in non-human primates of just insane muscle growth, increased strength in the absence of any external loading or training, just absolutely jacked mice and monkeys. And they were telling us that they were about to do trials in human children with muscular dystrophy. And so this instructor had me in the palm of his hand. And so whatever he said, I was like, oh, definitely, for sure. So I wouldn't recommend that as a general heuristic for how you approach your life and evaluating resources. But 19-year-old me was I was over the moon, and I was like, whatever you say, I'm all in.
Yeah, I think it's a really good point, and I agree very much so with Helms' answer to that last one, which is, to me, this is a question for the scientists to worry about, in that your training is unlikely to change, because even if hyperplasia does occur, and for the record, I do think that hyperplasia occurs and contributes, I don't necessarily think it's as much, but that's a kind of splitting hairs type of deal, whether it's 5%, 10%, whatever. It's that if it does, we don't know that it takes this crazy, super hard training to make that happen. It might be super normal training. I believe in Ruffalo's study, they were training at about 80% of 1RM-ish, something like that, right? Failure or rep or two shy failure, very normal training. And again, we're not saying hyperplasia occurred in that study. We have no idea, right? But it's that we don't know what type of training, like the degree, the intensity, the volume, would cause this to occur. And even if we did, well, are there gains on the table to be made before we even get to that point where we do this crazy training? Does it occur with pretty normal training and then it's accelerated if we do this crazy training? I don't know. We don't know. And I think that does hyperplasia exist to be officially confirmed maybe one day, and then the degree at which it matters, that is unlikely, even if we find those things, which if we do, super cool, unlikely to affect exactly how you train. So carry on as normal, and then maybe, episode 600, we'll check back in with somebody's found this by then, maybe episode 900, I don't know, and give the scientific answer. But it is an example of the ultimate scientific answer. Let the scientists worry about that. Keep your training going, keep doing what you're doing, because it's a cool topic of discussion, but probably unlikely to meaningfully impact what you do.
All right, folks. Great discussion about some nerdy muscle physiology. If anyone has anything to add before we wrap up for the night, by all means, state now or speak now, or forever hold your peace. Otherwise, I think it's probably time to wrap up. Usually at this time, I start blaming Mike. He's the guy that wakes up at 3 a.m. So I say, Mike's probably getting pretty tired. But the video evidence will show I did yawn several times despite the engaging nature of this conversation. As always, I have to give this disclaimer all the time. By the way, I sleep every night, an appropriate amount, but I just yawn a lot when I podcast. I don't know what the deal is, folks, but love the chat today. Appreciate the whole Mass crew for showing up. And folks at home, if you are wondering, when is the next episode of Iron Culture? When's the next episode of Mass Office Hours? Well, it turns out they are one and the same. Okay, so the next episode of Iron Culture, presented by Mass, the fusion of these two entities in the fitness space, institutions in the fitness space. The next episode is going to be live on YouTube Monday, November 18th, and that'll be hitting your podcast platforms on Wednesday, November 20th. So everyone, thanks so much for joining us. Have a fantastic week, and we'll be back soon.